So let's start the topic differentiation. See, before understanding about the differentiation, let me tell you something. Suppose we are having a relation in between x and y denoted by y equal to fx. So let us have a relation in y and x such that y is equal to, let's say, fx. So if the relation in x and y is written as y equals to some function of x, so if I plot the graph of this relation, then let's suppose the graph is like this. Suppose the graph is like this. Now if I talk about the value of the function at this x, let's say this is x equal to a. So at x equal to a, the value of y will be f of a. Put here x equal to a, you will be getting f of a. That means this height is fa. That means if I talk about the point coordinates, this point has coordinates a comma fa. Fine. Now suppose I talk about this point, let's say x equal to b, and I take the value of y at this point. So you will be getting fb. So this point will be b comma fb. That's okay, no problem. Now consider this point x is equal to c, and this point x equal to d. At this point the value of y coordinate is f of d, and at this point the value of y coordinate will be f of c. Clear this much. Now if I consider this interval from a to b, you see in this interval a to b, the value of y is being increased, and in this interval also c to d, the value of y is being increased. But what is the difference between these two regions, these two parts? See, in the first part, if I draw this horizontal line, and if I consider the vertical change, so for the gap between a and b, this would be b minus a gap. For the gap in x coordinate, b minus a, the gap in y coordinate is this. Let's say this gap is delta x and this gap is delta y. Similarly, if I consider this interval c to d, the gap in x is this much and gap is y is this much. Now if I say in which part the rate of increment of y is more, then you can simply say in the second part y is increasing more rapidly as compared to first part. Because suppose this gap is same for both. Let's say this gap is same for both. If the gap is same, so you can say for let's say 1 unit. So for 1 unit change in x, change in y is delta y here. And for 1 unit change in x, change in y is more as compared to delta y. So if I want to study the rate of change of y with respect to the rate of change of x, with respect to change in x, that would be represented by, if I want to write now, average, if I want to write average rate of change of y with respect to x in the interval a to b. you can simply say it is delta y upon delta x. Is it or not? Average change of y with respect to x in the interval a to b means what? The change in y upon change in x. Why I am saying this is average change? Because it is in some interval. It's not instantaneously. It's in some interval. This change can also be written as by the slope of this chord. If I join these 2 points through a straight line, let's say this is A and B, this change delta y upon delta x can be written as slope of chord AB. I hope this much is clear. So average change of y with respect to x is what? Delta y upon delta x. Delta y upon delta x is what? Is the slope of chord joining the initial point to the final point. Clear? Now this delta y upon delta x is not the differentiation. Differentiation is something else. Now, if I talk about instantaneously, let's say at this moment of time or at this moment of x, at x equal to a, I want to ask you what is the rate of change of y, and then I'm asking you at this moment of point or x equal to b, I'm asking you what is the rate of change of y. So now I am talking about instantaneous rate of change of y at x equal to a and at x equal to b. So you will be saying that at the point a, the graph is increasing, y is increasing, but at the point b, the graph is increasing more rapidly. So you can simply say at x equal to b, instantaneous rate of change of y with respect to x is more. Now thing is how we can calculate this. This instantaneous rate of change of y with respect to x is called derivative of y with respect to x. So this instantaneous rate of change of y with respect to x is called derivative of y with respect to, why we are saying with respect to x? Because we are considering the rate of change of y with respect to x. That means if I am at x equal to a, then by what speed y is increasing, you can say, and when I at x equal to b, at that moment by what rate it is increasing, y is increasing. So we are basically interested to find the rate of change of y with respect to x at the moment at x equal to a or at x equal to b. So instantaneous rate of change of y with respect to x is called the derivative of y with respect to x, and it is denoted as y dash or dy by dx or f dash x, okay, or let's say d bracket y or y1. All these are the ways to write derivative of y with respect to x, or you can also write f1x. These are all same things. Now the question arises how we can calculate this instantaneous rate of change of y. So let's come to that. Suppose we have this graph of y equal to fx. Fine. Now let us take this is your x equal to, let's say, a. Okay. And if I take this point x equal to a plus h, then at this point x plus h, the value of y will be f of a plus h, and at this point the value of y will be f of a. Now if you take this point is a, this point is b, and if I join a to b, so what would be the slope of this chord AB? Slope of chord AB will be change in y upon change in x. So if you draw the horizontal line, then you can clearly observe the change in y will be f of a plus h. This whole height is f of a plus h, and this height is f of a. So this much bm will be f of a plus h minus f of a. That means slope of chord AB you can write bm upon am. That means f of a plus h minus f of a upon am. What is am? At the point m, x coordinate is a plus h. At the point m, x coordinate is a plus h, and at the point a, the x coordinate is a. So the gap between them will be h. You can understand, a to a plus h, which if we are moving, the gap is h. So h. So if I write this, f of a plus h minus f of a upon h. So that's what? That is the slope of chord AB, or you can say that's average change of y with respect to x in the interval a to a plus h. Now we are interested to find instantaneous rate of change. That means we want to find f dash x. Okay, derivative. So what I will be doing, if I want to find the rate of change of instantaneous rate of change, so instantaneous rate of change of y with respect to x at x equal to a, we want to find. This will be what? This can be obtained by reducing this h to 0. Suppose if I move this point, to this point, this side. If I move this point to this side, that means we can say if I reduce the length h, that means if I move this x point towards this side. So if I make h 0, tending towards 0, it's not actually becoming 0, it is approaching towards 0. That means this am gap will be reducing. We are not moving x equal to a point, we are simply moving x equal to a plus h point this side. So think, if I move x equal to a plus h point this way, that means I am reducing the value of h. Then after some time it is becoming at x equal to a. That means b is moving towards this point a. As b is moving towards a, look at the slope of chord AB, how it is being changed. This chord AB, how this chord AB will be changing. This point B will be moving to this side, and the chord will be tending towards the tangent at point A. You see, suppose if this is the tangent at point A, suppose let's say This is the tangent at point A. So you can understand, if I move the point B, okay, if I move the point B towards A, this is AB chord, and if I move this point B towards A, the chord is approaching towards tangent. That means the derivative or instantaneous rate of change of y with respect to x, that means derivative of y with respect to x, can be obtained by limit h tends to 0, and slope of chord AB we can write f of a plus h minus f of a upon h. That means if I write the slope of chord AB when h is approaching towards 0, that will give you the slope of tangent at point A. That means instantaneous rate of change of y with respect to x at x equal to A is nothing but slope of tangent at point x equal to A. I hope this should be clear. And this is denoted as f dash at x equal to A. That means f dash of A it is. And dy by dx at x equal to A. Okay, this is not exact dy by dx, it is dy by dx at x equal to A. So from here you can understand that the dy by dx at a point x equal to A can be written as limit h tends to 0 f of a plus h minus f of a upon h. So that's the simple formula. And what does this signify? This signifies the slope of tangent to the curve at point where x is equal to A. So let me give you one simple question to you. Suppose if I'm asking you, find the slope of tangent to the curve y is equals to x square at the point 2, 3, 2, 4. It's not 3, 2, 4, because if you put x equal to 2, it will become 4. Basically, what I want to ask the slope of tangent to the curve y equal to x square at point x equal to 2. So you know the formula. Slope of tangent to the curve at x equal to A is what? Slope of tangent to the curve at x equal to A is this limit. That means slope of tangent to curve y equal to x square at x equal to A will be equal to this limit. You can write limit x tends to A. A is what? 2 here. So let me write it 2 here. So slope of tangent to the curve y equal to x square at x equal to 2 will be, in place of A we will put 2, because this slope is at x equal to A and we want slope at x equal to 2. So in place of A we will put 2. So this limit will be modified as limit not x tends to, it would be, let me correct this, x tends to x equal to 2 and limit h tends to 0. Okay, limit h tends to 0 f of a plus h. So in place of a it is 2, so 2 plus h minus f of a. F of a means f of 2 upon h. Clear this thing? So that's the slope of tangent at the point x equal to 2 to the curve y equal to x square. Now we will evaluate this limit and we would be obtaining the slope of tangent. So now let me write this limit once again. Limit h tends to 0 f of 2 plus h minus f of 2 upon h. What is fx? You know, y equal to x square was given. If you compare it with y equal to fx, you will get that fx is x square. So f of 2 plus h will be, f of 2 plus h will be, in place of x you write 2 plus h, that would be 2 plus h whole square. That means this limit will become limit h tends to 0, f of 2 plus h can be written as 2 plus h whole square minus f of 2 can be written as 2 square upon h. That will give you limit. This is a limit simple. You can solve this limit now. But before solving, if you put h equal to 0 in numerator and denominator, it will become 0 by 0 form. See, 2 plus 0 whole square, 2 square, minus 2 square, 0 upon 0. So before solving this limit, let me try to cancel some factors from numerator and denominator. So what you do, you write it as a square minus b square, a plus b, a minus b, identity. So that will become 2 plus h plus 2 into 2 plus h minus 2 upon h. So this will give you limit h tends to 0, h plus 4 into h upon h. This is 2 to cancel, and h upon h will also be cancelled. So you will be getting limit h tends to 0, h plus 4 only. Now put h equal to 0 here, so that would be 4. That means the slope of tangent to the curve y equal to x square at point 2, 4 is equal to 4. It means if you draw it graphically, you know y equal to x square graph is what? Y equal to x square graph, it's a upward opening parabola. In this way you can draw y equal to x square graph, and x equal to 1 is this point. Let's say x equal to 2 is this point. So if you draw the tangent at x equal to 2 point, the slope of this tangent will be what? 4. The slope of this tangent will be 4. So I hope you people are understanding what is the graphical meaning of derivative of fx at x equal to some point. Okay, so that means we got derivative of y with respect to x at x equal to a is equal to 4. Okay, at x equal to a is 4. That means you can also write dy by dx at, here not a, it is 2. Okay, at x equal to 2 we got now. At x equal to 2 is 4, and this is the point where x is 2, 4. So dy by dx at x equal to 2 is coming out to be 4. You can also write it as f dash 2 is equal to 4. You can also write it like f dash x at x equal to 2 is 4. You can also write it like f of f1 2 is equal to 4. So if fx is x square, then f dash x at x equal to 2 is 4. Now this is the thing, how to find the derivative of fx at some point. like x equal to 2, x equal to 3, x equal to 4, like this. How we can generalize the derivative of function fx? So you know f dash of a is what? Limit h tends to 0 f of a plus h minus f of a upon h. This is f dash a, or you can say derivative of fx at x equal to a. So if I want to find f dash x, so simply replace a by x. It would be limit h tends to 0 f of x plus h minus fx upon h. So that is the general derivative of fx with respect to x. You can also write it like d by dx of fx. I hope this thing is clear. So for finding the derivative of given function, we will be using this formula. Let me have one question. Suppose we want to find d by dx of sine x. This is the question, suppose. So you can relate here, fx is what? Fx is sine x. So we want d by dx of fx. So d by dx of sine x, or you know the formula, let me write the formula first. D by dx of fx is what? Limit h tends to 0 f of x plus h minus fx upon h. Now in place of fx, replace sin x. So it will become limit h tends to 0 sine of x plus h minus sine of x upon h. Now if we are able to find this limit, then we can find the derivative of sine x with respect to x. So now let us find this limit answer. So we got derivative of sine x with respect to x as limit h tends to 0 f of, we got sine of x plus h minus sine of x upon h, not x, upon h. Look at here, sine of x plus h minus sine x upon h. This we got the derivative of sine x. So limit h tends to 0. Now to solve this limit, if I put h equal to 0 here, I would be getting sine x minus sine x upon 0. Sine x minus sine x is again 0. So 0 by 0 form. So whenever 0 by 0 form is there, we will try to manipulate the limit, or we can cancel the factors, or we can use some standard limits. But here, before doing so, we would use some trigonometric identity here. So one of the trigonometric identity of sin c minus sin d, you know, sin c minus sin d is equal to 2 cos c plus d upon 2 into sin c minus d by 2. That's the trigonometric identity. So we will use it. 2 cos c plus d by 2, that means x plus h plus x upon 2. So x plus h plus x upon 2 into sin c minus d, that means x plus h minus x upon 2 upon h. Now this will give you limit h tends to 0 2 cos 2x plus h upon 2 into sin h upon 2 upon h. This 2 I will write here. Let me erase this 2 here, and this 2 we can take in the denominator of h, so it is h by 2. Now you can relate this limit. This is what? Limit s tends to 0 cos of 2x plus h upon 2, and this is sine of h upon 2 upon h upon 2. So see, the argument of sine is approaching towards 0. As h is tending towards 0, so h by 2 is also becoming 0. Denominator is also tending towards 0. So this is something like sine 0 by 0 form. The answer for this limit is 1. And cos of 2x plus h upon 2, you put h equal to 0 here, you will be getting cos 2x upon 2. That means cos x. So cos 2x upon 2. So finally, the answer for this limit is coming out to be cos x. So you got the derivative of sine x with respect to x as cos x. So this is the general derivative, or you can say general derivative of sine x with respect to x. But if I ask you, what is the rate of change of sine x at x equal to pi by 2? So simply put here x equal to pi by 2. Cos 90, 0. That means you can say the rate of change of sine x at x equal to pi by 2 is 0. That means the slope of tangent to the curve y equal to sine x at x equal to pi by 2 is 0.